Okay, we're going to take a look at the problems that are applicable toward integration and what we've been doing since the last test. First problem we're going to look at is BC2, which is obviously a definite integral. The important part about this is being able to see that it's a U sub, first of all. Second of all is being able to evaluate it using the graph above. So I'm going to split this into two integrals. The integral from -1 to 0 of f prime. And my pen is going to give us problems, and that's going to not be good. Minus 2x dx, and then minus from -1 to 0 of 4 dx. Okay, so we're just going to look at these separately because we can. All right. This piece of the puzzle, which we don't want to forget over here on the end, is just -4x evaluated from -1 to 0. So we'd get -4 times 0 minus a -1, which is -4. So when I get done with my U sub, we're going to subtract 4 from it, and we'll be good to go. This is a U sub because there is a function inside of f prime whose derivative is something other than 1. So let's start off. U is 3 minus 2x. Du is -2 dx. And -1/2 du equals dx. So I'm going to rewrite this integral. -1/2 f prime of u du. Notice I've left the limits of integration off right now because the -1 to 0 over here is in terms of x and my integral is in terms of u. And we talked in class on how you could handle this two ways. You can integrate it, get f of u, put the 3 minus 2x in, and then evaluate it from -1 to 0. The other thing you can do is you can take that x equals -1 and say u then is 5, 3 minus a -2, and get 5. And then when x is 0, you get u to be 3. So I think that's what I'm going to do. I'm going to put 5. I'm going to try to because the pen just won't work, to 3. Now, this is the same pen I use every day at school, and I don't know why at home it wants to act up like this. But maybe it's just the videoing. I don't know. So -1/2, the antiderivative of f prime is f. So we have f of top, 3, minus f of bottom, 5. And now let's go up to our graph of f. F of 3 is 2, and f of 5 is -2. So I have -1/2, and I have 2 minus a -2, which is 2 plus 2, which is 4. So -1/2 of 4 is -2, and we have the -4 here and the -2 here, and our answer is -6. Box, and let's go. Number 5, use a left Riemann sum with 3 subintervals. We've got a nice little chart here, so we should be able to do this fairly easily. And then interpret the integral meaning in the context of the problem. So let's mark up our chart. 0 to 1 has a width of 1, 1 to 4 has a width of 3, and 4 to 6 has a width of 2. So we have to do these 3 rectangles separately. The 1/6 integral from 0 to 6, I already know that I'm looking at average value of P of t. So 1/6, and we're using left, so left, left, and left. So 1 times 8 plus 2 times 3 plus, no, 3 times 3, sorry about that. I can't read my own writing. And 2 times 5. And we'll just leave that for now since the pen's working minimally. All right, so what does this mean? It is the average people per second. What are these people doing? They are entering the school. And we'll incorporate the time interval from t equals 0 to 6 seconds. And I think that ought to do it. We've incorporated the average because of that. People per second is the units of P of t. We've put it in the context of the problem, entering the school, and we've talked about specifically the time interval that they gave us, 0 to 6. All right, next page. I really love this problem. It's cool. We have a integral here that we don't really realize we have. They've given us, this is the graph of f prime, and on BC2, they want to know the minimum value of f over the closed interval. We get minimum values potentially at the endpoints, so we're going to evaluate the endpoints. We're also going to evaluate any critical values that we find over the interval. In looking at the graph, we can see that f prime of x is equal to 0 at x equals 1 and x equals 6. I want to at least let me or College Board, whoever's grading this, know that I'm looking for every place where the derivative is 0, first of all. I'm going to throw x equals 1 out because this is a relative max, and so there's no way that a relative max is going to produce the overall min. So I'm looking at evaluating three things here. The endpoints, f of -3, my critical value in between, f of 6, and then my final endpoint, f of 8. How do I do that? Well, this is the graph of f prime, so if I integrate f prime, I can get back to f. I also have kind of an initial condition here. This isn't like solving for C initial condition because you don't have a function to begin with. So we're going to use the first fundamental theorem here. I'm going to say that the integral from -1 to x of f prime of x is equal to f of x minus f of not -1, but +1. There we go, f of 1. And f of 1 is -2. So that's +2. So if I subtract it from both sides, I get -2 plus the integral from 1 to x of f prime of x is approximately equal to f of x in this case because, no, I think it actually is f of x. My bad. There we go. All right. So f of -3 is -2 plus the integral from 1 to -3, which is very backwards, of f of x. Okay. So 1 to -3 is actually backwards. So instead of being 10, if we reverse the order, it's going to be -10. So this is -12. So there's our starting point. Let me make some more room here. F of 6, our other potential min. Same deal is -2 plus the integral from 1 to 6 of f of x dx. And the integral from 1 to 6 is entirely below the x-axis. So its value, even though its area is 14, its value is -14. And so this is -16. Now I can see that from 6 to 8, I'm actually accumulating positive. What did we say this was? -16. So I know it's not going to be the answer, but honestly, I'm going to just commit and finish this. So f of 8 is negative 2 plus the integral from 1 to 8 of f of x. So I've got negative 2 minus 14 plus 6. Okay? And so negative 16 plus 6 is negative 10, and our min is this value of negative 16. Okay? Cool. All right. Then it also says that for a particle, so I'm on BC4 now, and they have defined f prime of t to be v of t. Find the total distance traveled. Total distance traveled is different from displacement. We could talk about the displacement from 1 to 8. The displacement from 1 to 8 would be what? Negative 8, because negative 14 plus 6 is negative 8. However, we're finding distance traveled. So we moved 14 units to the left plus 6 units to the right for a total of 20. So you see what I did here is I'm going to write down the integral from 1 to 8, and I'm going to take the absolute value of f prime of t, which is going to give me distance traveled versus displacement. Again, I took the graph, I flipped it up. My screen is, oh, there we go. It was frozen for a minute. Sorry, guys. 14, so I popped it up here. 14 plus 6 is 20. Okay? We're going to be not doing anything on the next 2 pages. Those will all come along later in the year. And I don't think that one. And here we are. So let's see. We can add D. Use a right Riemann sum with 4 subintervals to approximate the integral from negative 2 to 6 of h prime of x. We got a beautiful little chart here with h prime of x. We're going from 2 to 6, so negative 2 to 0, 0 to 2. Those are 2, so I'm thinking that my widths are all the same, and then I keep going, good for me, and see that the next one is 1, and the last one is 3. So we have to do these separately, okay? So let's find out the integral from negative 2 to 6 of h prime of x dx is equal to 2 times, okay, we're using right, so there's the right hand side of the first one, the second one, the third one, and the fourth one. So negative 2 times negative 2 plus 2 times 0 plus 2 times 2. That's not 2 times 2, it's 1 times 2. And 3 times 7. All right, now, given that h of negative 2 is 3, use the Riemann sum to estimate h of 6. First fundamental theorem again. So we know that this value, which let's go ahead and find it, negative 4 plus 2 is negative 2 plus 21 would be what, 19? That look good to y'all? Okay. So 19, that integral, is approximately equal to, I'm going to use the first fundamental theorem, that would be h of 6, which is what we're looking for, minus h of negative 2. But they told us h of negative 2 was 3, so h of 6 is approximately equal to 3 plus 19, which is 22. Again, this is 3. And so I just added it over. Now, use the Riemann sum, and is the estimate less than h of 6? So we've used a right Riemann sum. Let's write that down. And then let's take a look at some information that we've ignored to this point. It says that h prime is increasing. If h prime is increasing, then what do we have here? We're going to write Riemann sum and increasing. And I'm going to see what that looks like. I'm going to try to. There's increasing. And if I use a Riemann sum, it looks like we have, is it estimate? No. It is greater, because it was an over approximation. Next problem, use a trapezoidal sum with 3 subintervals indicated by the table. And now we're going to go to k of x over here. And we are going to use this first row because we are approximating the integral of k of x from -2 to 4. And hallelujah, would you look at this? These are all 2's. So remember, these are the heights of your trapezoid, because it fell over and it's laying down, so it looks like a width. And then all of these values are the heights. So let's see what we've got here. 1/2 is built into the formula, times 2, which is our height. And then let's come in here. We get 15 once. We get 0 twice. We get -1 twice. And I know that doesn't look like -1. And we get 5 once. Okay, so that is our trapezoidal sum. Is it an overestimate or underestimate? This time we're not going to look at the first derivative, but we're going to look at the second derivative. We're going to talk about concavity. And let's see what we can find out here. If k prime is increasing, that implies that k double prime is greater than 0. Okay, so we are concave up. Let's look at concave up and how that relates to a trapezoid. If I put 3 in here, then those sides of the trapezoid lie above the curve, or above the curve, so we have an overestimate. So therefore, overestimate. Okay, last page. I think we have another U sub and then another trapezoidal sum to look at. So here we're going to do pretty close to what we did on the first problem. This is a U sub. The derivative of 4 minus x squared is -2x dx. And that makes me pretty happy because I've got this x out in front that I need for this to be a U sub. So -1/2 du equals x dx. And let's rewrite our integral entirely in terms of u again. So -1/2, the integral from something to something, I'll come back to, of f prime of u du. So that's my substitution for the integrand and the dx. And now let's change our limits of integration. When x is 0, it looks that u would be 4. And when x is 2, u would be 0. So we're going from 4 to 0. Okay, first fundamental theorem, -1/2 f of 0 minus f of 4. We're going to go to the chart up here. F of 0 is 3, and f of 4 is -7. So -1/2 times 3 plus 7, and -1/2 of 10 is -5. Okay? Pretty cool problem. If you don't believe that this will actually work out the way I say it will with the changing, when you would do this normally, you would say this is f of, and you would put the 4 minus x squared back in, and then you would be evaluating it over the original 0 to 2. And look what happens. When you put in 2, you get f of 0, 4 minus. So that's exactly what we have here. And plugging in 0, you get f of 4. So it's up to you whether you want to go back to x and use the original limits of integration or stay in u and change the limits. Last problem, trapezoidal, using a trapezoidal approximation with 3 subintervals. Yay, we all have equal widths again, so we don't have to do these trapezoids separately. And approximate the average value. We don't want to miss that. So 1 over b minus a, the integral from a to b of f of x. We're taking the average of f, and we're going to go to the chart. So we've got the 1/6 from the average. We've got the 1/2 from the trapezoidal formula for area. And then we have the common width or height, which is 2. And then here we go. We have, can't read it, 3, doubling 4, 8, minus 14, and plus 5. Yay, done. See you all on Tuesday. I'm going to have a study session during office hours on Monday, and I will be happy to record that for you. See you later. Bye.